Okay, so I have here one breadboard and one Arduino. Both of these things we have used yesterday also, so we are very well aware of them by now. So I'll be adding some sensors one by one. The very first sensor I'll be inserting here is from yesterday's sequence, for instance. I'll be using this DHT sensor. Yesterday, we have used this sensor with a DHT library. DHT.h was your library. Today, I'll be using this sensor with DF robot library. Just another way to use this sensor. The main idea for us is to learn writing programs and integrating multiple programs together. That is the main purpose today. And of course, everything will do focusing on a specific application, that is your plant health and environment monitoring. So let us start with this sensor first. As we all know, it consists of three pins that includes VCC, ground, and data. And yesterday also we have connected it. If anyone missed that, I can repeat that again. We'll connect VCC to 5 volt, ground to ground, and data to any of the digital pins that we can declare in the software also. But since I'll be connecting multiple sensors one by one into the system, so my main requirement here is to create dedicated 5 volt and 5 volt and ground uh, sections on this breadboard, so that further I can extend my network without any restriction on the availability of ground and VCC terminals. So for this, I'll be connecting two wires here. Let me get the adequate wires for this. First of all, here I have one black wire and one red wire. I'll be indicating for VCC and ground. So first of all, this point here I have is 5 volt. So I'll be creating here one 5 volt section. Similarly, I have one ground right here. And from here, I'll be creating one ground section. So two sections of my breadboard I have segregated here into VCC and ground right now. Based on this, I'll be connecting the hardware. We always know that the first connection we make for security is the ground. So this section with the black wire, I have the ground, and this orange one I can extend for the 5 volt further. So I'll be inserting it right here. And the middle one, wire for your data, I'll be connecting it on pin number 7 right here. So this is currently the hardware requirement for me. In order to interface this circuit now, I need a code. And that code will be creating here by following your Arduino IDE section. So I'll be sharing the screen for the code section here. Throughout the session, I'll be switching between code and hardware so that you can follow up with the process easily. So we'll be switching screens again and again. And if anyone finds any difficulty between screen switching, just let me know. I'm always trying to pin the screen that I'm using on focus so that you all can be well versed with the thing that I'm doing on my screen. So this section I have opened up here. One option is I can directly open up DF robot library, and from there I can get my example sketch for interfacing DHT sensor. But what I'll do here is I'll do it from scratch so that we can develop a practice to write your codes and we can understand every part of the code. So the very first thing we always do is I'll be listing here, include libraries. And in order to interface this particular sensor, the very first library we need is hash include df robot underscore dht11.h. This is one of the libraries I'll be using. And when we include libraries on Arduino IDE platform, we need not to terminate this particular syntax. It doesn't require any termination marks. So I'm just keeping it like this. The next task I'm doing here is for this df robot underscore dht11, I'll be declaring a dht object so that instead of calling this entire name I'll be calling just the nickname of it throughout the program for interfacing anything. And I'll be terminating also this. Make sure you follow the standards of programming, and it also requires you to follow case sensitive approach, otherwise you will get an error. So all those things we'll have to keep in mind. The next thing is, whenever you interface anything on the hardware, it is essential to define the pin number to collect your data. Since on my hardware side, the DHT11 sensor I have interfaced on pin number 7. So the same pin I have to declare it here for DHT11 underscore pin name I'm giving it, and pin number 7 I have dedicated to this. For this hash define symbol, again, we don't require any termination marks. So accordingly, I'm following it here. So what I'm doing here is basically declaring pin for sensor, and that is pin number 7. After this, the next task I want to do is, it will be variables for measurement. Now quickly, anyone can let me know in the chat box, what are the variables that we can measure with DHT11 sensor? If you remember it from yesterday's session, what parameters of
Temperature and humidity.
yes, right? So we'll be declaring here two variables, and I'll be declaring them as float type variables. It is your choice how you want to make your measurement, whether int or float. In my case, I want to store it as float variable, so I'm doing the same. Two variables I have declared here. Now this is the initial declaration part, and I'm done with it. I'll go to the setup section after this. Since I want to see my readings on the serial monitor, so for that we need to first initialize serial monitor with a specific baud rate that we have seen yesterday also. So serial.begin I'll write here. And inside this, for instance, I'm passing 9600 baud rate, and I need to terminate this as well. So the same I'm doing here, and nothing else I require, because this particular library doesn't require any kind of initialization. So I need not to do any dht.begin over here. Yesterday we have used dht.h library. That library also requires initialization in setup section. So there we were doing dht.begin. Within bracket we were passing just empty value because it doesn't require any baud rate. So these specifications you will get to know when you get friendly with the library, that whether some initialization is required or not. So for this, definitely a time long process is there. You will learn slowly when you practice things, and then you'll get familiar with this. So the setup section is done for us, and now we will switch to the loop section. And in loop section, we will simply use the existing function from the library. And inside this, we will use DHT11 underscore pin variable, which defines pin number 7, where we have connected your sensor. So accordingly, I'm trying to read from pin number 7. After this, in the first variable, temperature variable, I'll be storing the value of temperature, for instance. And similarly, in humidity variable, I'll be storing the value of humidity. And these are inbuilt functions again that I'm using. Within the DHT library, this technique is available. I'll also show you further that if library is not available, then how we read from certain pin. That also we are going to learn further. After reading both these values, now I'm ready to print them on serial monitor. So we have serial.print over here, and inside this, one is to pass your variable values directly, like I'm doing it with temperature and humidity. Note that if I do it in this format, it will just print the values of the variable. Means what is stored here, that will be printed, and then what is stored here, that will be printed. Will not get any name of the variable with its value. And if we just keep on getting values and values only in sequence, it will be difficult to recognize which one is temperature value, which one is humidity value. Although we can try that, and then we can see how we can modify a program to get clarity with the readings. So let us first try it up to this, and let us see what we get in the outcomes. So let me just run this to verify if we don't have any error. Then I'll upload it into your hardware side. So first of all, I'll select Arduino Uno board, and then I'll just compile it to see if we don't have any error, then we can proceed further. Okay, so a hash include. Okay, fine. I don't have the comment over here, so this I need to change. So if we have any typo further, it will give us an error. Otherwise, it should work. So we can see done compiling. First, let me run this on the hardware side, and then I can share this on your chat window also. Let us first observe what we get on the hardware side. So I'll just keep this window here, and side by side, we can pin this window as well. And the layout I'll change to spotlight. So I hope now both things are visible to all of you. And I'll just connect this USB cable on the USB port on of my system, and you can see Arduino turned on. And similarly, your DHT sensor light also turned on. So it means it is working fine. And we can choose the COM port also from here, since I keep on connecting Arduino wires time and again, so it can detect the port automatically. But when you start doing it for the first time, you may have to select port also manually. So I'm just choosing this COM5 here, and then I can click on upload. We'll wait for a while, it uploads, and then we can open up the serial monitor to see the outcomes. So it says done uploading, and now I'll open up serial monitor, and I'll just refresh it from the reset button over here. And you can see these values are being updated continuously. And this is like a continuous sequence of values. You cannot observe what it is printing. And also there is no delay in our program right now. So continuously it is transmitting data, and in one line it keeps on publishing this data. And you can observe on the Arduino also here, continuously the transmit LED is blinking because the hardware is continuously transmitting data. So that effect you can see right here on your Arduino blinking as well. Now we need to improve our code. We'll be updating all those things, don't worry. So now we are trying to improve our code. The very first thing we have here is we don't know the variable type. So in print itself, we want to improve it by adding the variable type. That is the first thing, serial.print. And for this here, I'll be writing a static text. Static text we always write within inverted commas. So here I'll be writing, for example, temperature. So I'll be just closing this here. Then we have for the second one, serial print, and then we'll be writing here humidity, and this one also right here. So these two sections I have created. Still, if I try to print it like this, there will be little difficulty in observing the outcomes. For instance, if I upload this program, we are just trying to observe the changes in the program one by one. So currently I have just added names here. I need to terminate this also, and then I'll upload it again. So based on this, we'll just try to see the outcome. I'll be just pressing the reset, and you can observe temperature, humidity values are being updated continuously. But again, the problem is The clarity in data, we are not able to see it clearly, that it is always updating in same line. We need to scroll like this to see next reading, and this is not taking any delay also. So there are like thousands of readings being published without any delay. It is continuously updating values. So we don't need this much fast sampling rate generally with the hardware. Rather, we need some delay for the proper sampling of data, because in this such a millisecond duration, there will be no major field change. So what we will do here is, one thing is, I'll add a delay of maybe 5 seconds. You can add any delay as per your requirement, maybe 5 seconds, 10 seconds. I'm adding a delay of 5 seconds. This is one part. Other than this, I'll try to get this output next to next line. So for this, what I'll do here is, I'll add a ln over here. This is print, this is print ln. To print in the next line, we write print ln. And it will take effect from the line after this. Means first your temperature will be published, in the same line value of temperature will be published, then your cursor will go to next line, then humidity will be published as static text, and then in front of this humidity value will be published. And here I'll post ln again, print next line. So accordingly value will go to the next line. And then in order to see a gap between next to next reading, I'll post here one empty bracket also, like this, so that the empty space gets published after this, and we can see the gap between next reading. This is just how we format the outcomes to get it in clear manner. Now I'll update this again, and let us see the changes in the output. So I'll be opening up this, and here I'll just first refresh it, then I'll close it, and we can see the outputs now. It is showing us updates with temperature and humidity values. And it is important to mention here that we are since using some basic sensors, and they not always require you accurate, provide you accurate values in first instance. Many sensors have a stability period of few hours, and they will give you some garbage values or random values in the beginning, and then they take some time to come up with the accurate values. So accordingly, we may need to wait for a while. So this is the first set we have learned about creating code from the scratch, and then getting readings over here. I'll be sharing this portion in the chat box, so that if anyone is doing it side by side, they can run it. I'll be sharing it in portions because it will not get the entire sequence in once. Also, those who are looking forward for the units of these measurements, that also you can update. You always need to verify the units from the datasheet of your sensor. In the datasheet, they mention whether it is measuring in centigrade or Fahrenheit, what unit it is using. In case of this sensor that I'm using, for instance, I can update it serial.print, and I'll be writing here degree Celsius. So that I'm updating here. Similarly, for humidity, it will be printing in the form of percentage RH. So that also I can update over here. But this information you always get from the manufacturer specifications, because different sensors can follow different way out for these measurement units. So this I'm putting with little bit of space, so that accordingly it gets published in your data. And the ln also I may need to move to the next line, so that units get published right after the reading. So these are some formattings you may have to do in the code accordingly if you want to publish units also for the readings. So I'm just updating it again. And now we can visualize the outcomes right here with the unit of measurement. So accordingly, you can update it. So this is the first code from the scratch we have just learned. Let me know if we all good up to this. If you have learned the first code setup, you can ping me in the chat box if we are all good up to this. Okay, great. So now I'm adding up one more sensor over here. That is your water level sensor. So with this water level sensor, you may basically need a water ball also, in which you can insert this sensor, and then you can see the measurement outcomes based on that. But side by side, we will also learn that how we can write a code for this, since this is an analog type sensor. So accordingly, we can build up a code. And then in the next phase, we will learn how we can combine this water level sensor and DHT sensor code together into one section. So the step by step things we'll be learning here. So instead of running it in the same portion, I'll be creating a new window here, so that I can again write a separate code for you. And then we will learn how we can combine both these codes together and run both sensors together. So this will help you to learn everything from the scratch. So let us first take out this power cable, so that we can make another wiring concept over here. And side by side, the code also we will write. So in the first part, I'll be just taking out the supply connection of this DHT sensor, so that we can just start working with the individual sensor, that is your water level sensor. So inserting this right here. So in this particular sensor now, we have this red one wire for the VCC. I'm connecting it here. Then we have ground that will be connecting right here, and then this data signal. Now, as I told you that this is an analog type sensor, and it is written here, S is written here on the pin name also. So we call it a signal pin, and that we can interface directly with the analog port over here. So I'm connecting it on the A0 pin. So in order to interface this, now let us learn how we can create a simple code for interfacing analog sensor. This is again depending upon how you prefer to do coding, you may find different approaches for this. I'll be using a simple technique, and then I'll try to modify it for better clarity, and we will learn the process thereby. First thing, this particular sensor doesn't require any kind of library. So there is no option for any kind of library you need to add. Rather, what we can do is, in the setup section directly, what I can do is I'll write a serial begin, and inside this I'll pass the baud rate of serial monitor. This is one thing. Second thing, for the analog sensor, we can proceed directly first. In the loop section, what I'll write here is, since this is helping us to detect water level, so based on this, I have declared one float variable right here. And then on the other side of this, I'll be just reading the value. And for that, we'll be using analog read function that is by default available, in your libraries. And inside this, I'll be just passing the value of, or the name of the pin where I have connected my sensor, that is on A0 pin. And then I'm terminating this. After this, I can use my serial print sequence, same as previous. And inside this, first I'll be passing the static text, that is water level, terminating this, then serial dot print. And inside this, I'll be passing this exact variable right here. And then for this, again, I can write here ln, and then space. I'll be using a little bit of space over here so that I can see the next line easily. And then I'll add a little bit of delay, for instance, 5000. So this mini sequence I can use to read any analog sensor directly. Let me first run this. If it works fine, we'll be uploading this code on the hardware. Okay, so this is working fine, and the hardware connection also we are done with. So I can connect my USB again on the laptop, and you can see the sensor also turned on. You can see a LED over here, and similarly Arduino also turned on. And if we have all the connections right, the DHT sensor I have taken away right now. We'll see that again. So I'm using here the serial monitor, and on this we'll try to see the print. I'll refresh the readings. Okay, the upload we have missed. Just wait for a while. We have just compiled but not uploaded. So I'm just uploading it now. And then I'll be opening up. You can see this is the current water level it is showing, because it will show the minimum possible value that it is getting. And I also told you that these sensors will not always provide you exact reading in the beginning. So accordingly, little bit of calibration you may have to do, or generally for high-end accuracy, we prefer recommending your advanced level sensors. In this, the basic values it will provide somewhere around 4 5, because it will sense little bit of moisture around also. Now, in order to check the measurements further, I'll be using here one water bowl. You can see I have placed some water inside, and you can see it is now on the lowest level. So as I'll insert my water sensor inside this, depending upon how much water I have cached up within the range of this sensor, you can see it is increasing. If I insert it more in depth, accordingly, the values will keep on changing further. Like you can see 350. I'll submerge it more and the value will further increase, 518. I'll insert more it down, and then you can see up to 539. So depending upon up to what range this sensor can measure readings, it will give some outcomes. And that range of measurement, again, you can see in the specifications provided by the developers. So this is just a quick visualization we have done for the sensor measurement. Now, one more part here I'll add is, currently you have just used it with a water level reading to be seen on the serial monitor only. But maybe in order to get a response out of this, like when we are designing a greenhouse system, if some plants are getting more than required water, means the threshold has reached already, maybe we would like to generate some alarm for that. That buzzer should ring, or maybe any indicating LED should turn on, so that we get notified that the water level has crossed its threshold level. That will be a smart control for your greenhouse, so that we can just turn off the motor at that time. So in order to do that, I'll just modify this code slightly, and I'll add a buzzer into the sequence. And for that, for instance, I have this buzzer module with me. You can observe this. This buzzer contains 3 pins, negative, positive, and signal. 3 pins again. When you are interfacing it in an individual circuit where positive and negative, everything is required separately, we can use 3 pins. But in our case, since we are using it with the microcontroller, what we can do is we can skip one middle pin. I can use negative pin for the ground, and signal pin I'll be using directly with any of the pins, because on Arduino board, whenever we have any output pin declared, that will automatically signal it with the 5 volt, so that it can just ring up accordingly. So that technique we can directly follow from the sequence. And for this, what I'll do is, first of all, I'll take out my USB cable so that I can insert this new hardware into my circuit. One ground point I'll be inserting first right here. And then, for instance, I'll be using maybe pin number 11 from here, or any of the pins you can choose. Maybe pin number 11 I'm choosing here for the buzzer indication. So accordingly, this yellow wire I have inserted right here. The same I have to declare on the software side as well. So in order to do this on the software side, now little bit of difference in comparison of previous program will occur. What we'll have to do is, you may also need to declare the type of pin, especially when you are working on a digital port. Because if you remember the previous sessions, I told you that the digital port can work as an input port as well as an output port. In case of analog port, it works automatically as an input port. So we need not to define the pin type. In case of digital port, since pin 11 is from the digital port, we need to define it specifically. So what I can do here is, pin mode command I can use in the setup section. And inside this, here, for instance, pin number 11 I have used, I'll declare it as an output pin, so that your Arduino automatically knows that it has to send signal out from here. So pin number 11 like this I have declared. Now we need a buzzer to ring on a specific level. So in the loop section, I may need to create a condition, so that when the water level is at a specific threshold, then the buzzer should ring. Otherwise, it can stay off. So what I'll do here, after printing the values of the sensor here, I'll create one condition that is with water level variable. And I'll add a threshold of maybe 500, because I have already seen the ranges of this particular sensor. It goes up to 539. So maybe 500 threshold I'm adding over here. Then inside this, I'll put up my code block. Note that since 11, this pin belongs to digital port. So in order to activate this particular pin, now I need to use digital write operation. You can observe that this is a very friendly platform. When you have to read from analog port, you can directly use analog read function. When you have to write to digital port, you can use digital write function. Similarly, you can use digital read function when you have to read something from the digital port. So digital write, I'm declaring here. 11 is my pin number for the buzzer, and I'm making it high. This is case sensitive again, so accordingly high with capital letters I'm writing here. And what does it mean? Buzzer on. When the value is above this threshold, buzzer should ring. And because I don't want to ring it for a longer duration, I'll add a small delay of 100 over here, or maybe 200, so that it rings just for a small duration without making any noise for a longer time. And then I'll add one else condition. The opposite of this I need to insert. And in that, I'll simply write buzzer to be low, so that it stays off when your threshold is not met. And for keeping this low, I need not to add any kind of delay, because that will be a permanent condition automatically. This will be high only for 200 delay, and accordingly that will be for greater than 500 threshold. So this is your conditional statement we have added, and what we can call it, interfacing your sensors and actuators together. This is what we are doing right now. Water level sensor is your input device, and the buzzer is your output device, and both of them we are now interfacing together. So I'll just compile this program, and if it doesn't have any error, I'll upload this to the circuit right here. I'll need to connect USB for that. Port I need to select, and then I'll upload again. So done uploading, and now we can observe the outcomes right here. Water level is very low right now, and I can just take the water ball again, and we'll try to observe the change in readings. So you can see, as soon as it crossed above 500, the buzzer started ringing immediately. So this is how your conditional statements will work within this controller. This we have learned right since first session. We are learning this, that we need to maintain a control with the output devices that will ensure you enhanced outcomes with your system design. So I'll just leave it for now. So this is your one complete setup with the water level sensor. Now, since we are designing one application over here, that is for monitoring your plant environment. So in order to do that, what we can do here is we'll first learn to combine program created for these two sensors that we have just created recently. So we are just merging two codes right here. In order to merge these two codes, what you will need essentially, first we need to observe what are the repeated content and what is the unique content in this. So for any unique content, you can avoid combining, and for any repeated content, accordingly, you can follow over here. So for instance, I have this section for the water level and this section for DHT sensor. What I'll do is the outside setup section I can keep as it is in this DHT code. However, in this particular section, I can use the pin mode. I'll copy it from here and I'll place it right here. So after copying this code, now next part we have is in the loop section. The remaining setup section we can keep as it is. So in the loop section, I can create sections now for easy understanding. What I'll do here is DHT sensor reading, I'll write here. And then second thing I'll do is water level sensor. So in this section now, I'll copy this portion of the code. And up to this level, I'll add it here. So now we can observe this section is also done. Now, in order to improve our code, what we can do is, instead of declaring this variable here, we can declare it along with other variables on the top right here, so that everything stays organized in your code. And for this, what we'll do here is, this float we will remove and just the water level we'll keep here. We can check remaining portions also. If anything is not repeated, then this should be fine, and we can try running this. And if there are no errors, we can connect back the hardware. We can just remove this portion, and from here we can directly connect back the hardware for the DHT sensor that we have used earlier. So I'll just take out the wire, and from here first VCC I'll connect, then ground I'll connect, and then this pin number 7 I'll connect. These were the essential pins that we required. Then I'll update it here, and we will just upload this code first of all, and then we'll try to observe the readings for both sensors altogether. Now we can see this is for the first sensor set, and then for the water level we are getting, and the remaining readings accordingly we are repeating here. So if you need to organize anything, like for instance this we can remove so that it comes with the next set of the reading. This delay we can put by the end of the print sequence, or maybe even after the uh, conditional statement. So we can upload it again, and then we can observe how clean our outcomes have turned out to be. So this is your sequence now. For water level also, you can check how the sensor measures it, what specific thing they use for the water level measurement. It is generally in mm's, depending upon what type of sensor you are using. So accordingly, the unit also you can place over here. And the buzzer we have already placed, so accordingly, things will line up. So this is how we merge sensors and actuators together. Let me know if we are all clear up to this. Ping me in the chat box.
Yes, ma'am.
Okay, fine. So now we are moving further, and in order to set up the sequence, for instance, this is right now my added up sequence, and this portion of the code I'll remove from here, and this I'll use to add up more sensors in sequence. For instance, the next sensor in sequence I have is a simple gas sensor that is from MQ series. This one. We have seen this on the first day also. This is a gas sensor that you will find from the MQ series. These are very low cost sensors within a amount of like 100 200 rupees. You will get easily these MQ series sensors, and they can measure different types of gases. Currently I have here is MQ135 sensor that can measure your CO2. So accordingly I'll be updating that into my variables, since our current application is to monitor the environment in the greenhouse area. So that there some kind of gases are also present, and they also impact the health of your plants. So one of those I have used here as CO2 measurement unit, so that we can understand how much CO2 is being released in that particular area, and how they may affect or improve plant health. For different types of parameters we can do that analysis. So what we have in this sensor again, there are 4 pins, out of which 3 pins I'm using VCC, ground, and one A0, because I'll be taking data on the analog pin. So accordingly I can update that here. So what I'll do is first I'll use the ground pin from the sensor that I'll connect in the ground section right here, and then I'll use this VCC pin. I'll connect it in the VCC section, and this signal pin I'll connect, for example, on A1, and this sensor is also connected on the hardware now. So further here in the code if we have to do it from the scratch again. So what we have is, one is your void setup section, and inside this void setup section, simply you will need to write serial begin with your baud rate of 9600. Similarly, in your void loop section, we may need to write the repeated code. And for that, the simple sequence that we have learned earlier, that is your float variable for CO2, and then analog read. Now the pin number I have is A1. Similarly, serial dot print I can use here. That will be static text as CO2, for instance, and then I'll be using dynamic text with CO2 variable that I have used recently. And I can use here ln, and similarly serial dot print for little bit of empty space for clarity in outcomes, and then a delay of 5000 I can add over here. So this simple program again I have created for interfacing gas sensor. I'll just run it and let us see if it works fine. We will put it on the hardware. Currently, I have connected all the hardware points over here, but when I'm uploading a code relevant to only one pin, so only that pin will work at that point. Even if you have connected multiple hardware, it has nothing to do with that. So it will focus on what software has been updated to the sequence. So I'll just upload it, and now I'll open up the sequence here, and we'll try to see the outcomes. So this is showing your CO2 reading. I have not updated the parameter, so you can update that parameter unit. That also you can update here. For instance, serial.print, and this will measure it in the form of ppm. So that I'm updating here, and we'll write here ln, and this ln we will remove, so that accordingly your outcomes get published over here. So uploading it again. And now checking out the outcomes from the sensor itself. So these are the outcomes we are getting from the sensor right now. Now this sensor also we need to merge into the main code, because now our hardware is expanded to 3 input devices and 1 output devices. So accordingly, we need to expand the code as well. So for instance, this section of code I'll take again. I'm just showing you the beginner friendly steps, how you expand on hardware and software, so that you can take it up to any level in future without any restriction. Now the section for DHT sensor I have here, then water level sensor section also I have here. So for easy understanding, I'll create one more section over here that I'll call CO2 sensor. And inside this, I'll pass on this portion only, because delay I already have over there. So I'll pass this in the loop section. I don't have anything new in the upper section, so I'll keep it as it is. So based on this, I can run the part again, and I'll just remove this one from the previous, so that these readings get combined together automatically, and the space comes only after that. So I'll just run this again on my hardware, and let us see the outcomes all together for 3 sensors and 1 output device here. So now we can observe for temperature, humidity, water level, and CO2, we are getting the outcomes. I have little bit of water gathered here due to the sensor submerged, so that is why some readings it is showing. So accordingly, you will observe the outcomes from the sensor. So this is how the third sensor also we have merged. But now I'll show you one more part over here. As we are increasing our sensor code, the main problem you will observe here, that happens even with professionals and beginners, everyone, that when you are declaring things with these pin numbers like this, it gets sometimes difficult to remember which pin number you have assigned to which type of sensor. Like if suddenly someone asks you that what you have connected on pin number A2, A5, so you will have to find it like this in the entire code. And when your code grows up to like hundreds of sensors or maybe 10, 20 sensors, it gets difficult to identify your pin numbers from there. So what we prefer for that, we prefer some easy technique, that is to organize all your variable names on the top. So since here you can see variables for measurement I have declared earlier. Similarly, what I'll do here is in this section, I'll declare variables for sensor pins. Earlier, I have done this only for DHT11 sensor because that was a library based sensor and this was a requirement over there. But for all the sensors and actuators that are connected on analog or digital pins, we recommend creating specific names so that from that name directly you can identify your pin and it will be segregated in a specific section of your code also. So what I'll do here is I'll write again hash define, and the second sensor that I have added up was your water level sensor. You can give it name like water sensor because water level name I have given to the measurement variable. So water sensor, and I have connected it on pin number A0, and I'll write here this one is for the HT11 sensor. This one is for water sensor. Similarly, hash define I'll use for CO2 sensor. We need connected words for this. And this is on pin number A1. So pin for gas sensor I have updated here. Similarly, one more thing I have used is your buzzer. So I'll write here buzzer. Simple buzzer name I'll give it because buzzer pin I may have used somewhere else. Okay, no, buzzer pin I have not used, so I can give it a name like buzzer pin. So that will be on pin number 11. So pin for buzzer comment I'm adding here. And now what I have to do is further I need to replace things like this. Instead of using numbers, now I will be using names throughout the program. So that will be like a professional approach to handle your organization of the code. So first I have updated with the water level sensor, then I'll be updating with CO2 sensor that I have connected right here. And after this, I have it for the buzzer pin, that is pin number 11. So that is basically in my loop section. So here I'll be updating this one, and here also I'll be updating it. Now this is like a organized form of your code. So after this, if you add like 10, 15 different sensors, all of them will be segregated in this section and you can identify easily. And accordingly, just by looking at this section of your code, you can complete your hardware wiring. Because one by one, you will check sensor pins and accordingly, all the pins you can do. This is a standard format that you have to use. When we write analog, we always write A0, A1, A2, that is Arduino specification. And when we write digital pins, we always write pin number only. This is the standard specification we have on the Arduino. This is how on the Arduino board itself it is written also. So you will not get confused because on the board itself, the pins are written as A0, A1, etc. and 1, 2, 3, etc. So the same we have to follow. Otherwise, it will not be able to identify your pins and you will get an error that this is not a authenticated pin on your Arduino board. So these things I have now organized. Let me see if everything is right with the program. I'll just compile it to ensure there are no errors. I can see one error. So it says it needs some termination is missing somewhere. Okay, with define everywhere I'm using termination, but we don't need termination with define. So I'm just removing that. All other things are fine. It says done compiling. So up to this level, everything is working fine with our code, and I'll just remove this one also now. And we will expand our code further with another sensor now. So for example, I'll be using, I have here one LDR. This LDR I have. So, for instance, while monitoring your plant health, the next hypothesis we are considering is like some plants in your greenhouse require little bit of lighting in the night hours also. That completely depends on what type of plants you have. Some complete darkness sometimes is not good for your plants. So for that we can use some artificial light also in the night hours, so that instead of controlling that manually every time, like sometimes it is not possible for us to go to the greenhouse and turn on mini light for the night hours, so we can do that with the help of LDR automatically. On the first day of my session also I told you that this LDR is popularly used for street light, automatic street light function. So here we are using it for automatic light management in the greenhouse area. So what we'll do is we again have 3 pins of this sensor that will be connecting on the hardware, and accordingly a software will be updating for this. And I'll be also using a LED as an actuator for this, so that whenever darkness comes, the LED should turn on automatically. So that effect also we'll try to observe side by side. So what I'll do is first I'll take up the ground pin. I'll connect it on the ground section of my hardware. Then the VCC pin, I'll connect on the VCC section of my breadboard. Then we have data pin. So for LDR, I'll be using a digital pin for the input output, because this sensor I'll be using just to read 0 and 1. Brightness I can code as 0, and darkness I may code as 1. So accordingly that I'll be defining in my code, and I can use it on any of the pins right here. For instance, I'll be using it on pin number 4, and 4 will be like 0 1 2 3, and this is your 4. So accordingly I have inserted all the pins over here. And now the next task I have is inserting code for this particular sensor. But before that, let me insert a LED also, so that I can write code for both parts parallelly. So I have this LED over here. Your LEDs always have 2 legs, and if you remember, one is anode, other is cathode. Can anyone quickly ping in the chat box, out of anode and cathode, which one we connect with the ground? If anyone can ping quickly in the chat box, whether anode or whether cathode we connect with ground. LED is one of the most important component that we learn when starting with any hardware. Great. So cathode we generally use on the ground side, and anode we use on the positive side to turn on your LED. So accordingly, I'll identify the anode and cathode terminal. I hope all of you know how do we identify that. There are 3 different indications of identifying your anode and cathode that we can do based on leg length, we can do based on flag, we can do based on cut on your LED. 3 different options we have. If anyone doesn't know about these identifications, they can let me know in the chat box. Otherwise, we can just proceed, and I'll be connecting pin for this. Now, for instance, since this LED I'll be using as an actuator on the output side, so I'll be using one terminal from this common point of LED to any of the digital pin output, because LED again I'll be turning on and off. So I don't need analog signal for this. Since this is again an output device, so again this will be automatically taken to the digital port. So I'll be taking it right beside my LDR on pin number 3 over here. So pin number 3 and 4 now I have occupied with LED and LDR. Now the same I need to define on the software side. Now I'll be doing it on the main code itself, because I'll be segregating it very well over here. So define your first LDR pin we need to define, and that I have on pin number 4. Pin for LDR. Similarly, define LED pin that I have on pin number 3. So this is pin for LED. After this, a variable I need to declare. Okay, CO2 variable also we have missed declaring over here. I'll take that up. We missed it right here. This one I'll be replacing with CO2, and I'll take this one right here. and then float LDR. You can give any name, maybe luminosity or anything, light or anything that you want to put here. So I'm giving it name LDR only, or LDR value also, anything you can assign over here. The variables we always need for the sensors. For actuators, you don't need any variable because that is the output signal you will be sending directly from your code. So this section I have updated here, and then I'll go to here also I need, if you remember, for the digital pins we need to declare it very carefully. And here also one more thing I have to update that may have missed. This buzzer name I have to replace from the output declaration as well, right here. And then this one I have is for output on LED pin. This is my another output terminal, and similarly there is one input also this time on the digital port, and that is your LDR pin. I hope this is the name. Yes, LDR pin. This is a input device this time on the digital port, so we need to define this as well. Then only your input port will be able to judge the outcome, the response from this particular sensor. I'll repeat it again. The pin mode declaration are compulsory for the digital pins, but they are optional for the analog pins. So even if you declare or do not declare, analog port will still work as your input port, because that is by default input. So these standard procedure we may need to just keep in mind, and accordingly we can set up our sequence of codes. Then we have void loop over here, and inside this I'll create one more section of code that is with my LDR sensor. And inside this LDR sensor now I'll be showing you one variation also, that how these LDRs behave in general. First is my LDR variable that I'll be using for storing information. Here I'm adding digital read this time, because I'll be reading from the digital pin. So digital read, then LDR underscore pin I'm using here. After this will be just to read the value. I can print this value directly by using the LDR sensor variable here. Then we have serial dot print, and inside this I'll be passing the LDR variable itself. And after this I'll be using ln operator. Then again this thing basically I can copy below, so that the delay the gap comes after reading this part. So this is your print section. If you want to update your unit also, that you can do as well. For that will be a luminosity in case of your LDRs. If you are reading it in terms of analog signal, since I'm reading it as 0 and 1, so I don't need any unit right now, because this will just sense brightness and darkness only. Then I'll be creating my if condition to turn on LED. So what I'll write here is LDR is equal to 1, because I am showing two conditions only here. Now this is an interesting part. I'm saying when LDR is equal to 1. But in order to do this, I may first need to define a initial condition for my LDR, because we don't know whether your LDR by default will be assigning 0 variable to brightness or 1 variable to brightness. Either you may have to check the specification from the datasheet, that what they encode as default variable value, 0 or 1 for the brightness. Otherwise, second thing what we can do is, initially itself we can declare this variable type. For instance, the LDR value I'll use int, and this I'll make by default 0. So that what I can say is initial value assigned to LDR sensor output. So it will read 0 in a normal condition, that it considers as a bright condition, and one for the opposite condition, or based on what it senses first, accordingly it will be decoding the values further. So that definitely you can do multiple hit and trials, and then you can see which one by default it is reading according to your code. So currently we are doing here, by default value I'm assigning is 0 for this. And further, I'll go to the section, and here I have declared already that if LDR goes to 1, in that case I'll be updating my conditions, that will be within curly brackets. So inside this I'll use digital write again, and this time for my LED pin, this is my variable, and I'll make it high when this is the response is equal to 1. So it means LED should be on. And similarly, we can add a delay of maybe 100 or 200 depending upon for how much time you want to keep it on, or maybe you can just keep it high all the time whenever it is dark, so accordingly you can avoid the delay. That completely depends on how you want to this LED to behave. So in this case, I'll just add here digital write, and inside this again, for the LED pin, I'll write low, that will be the opposite condition. So LED off should be there. So this is my condition. After this, I have the delay itself. And let me first check this particular code, and we will just translate it to the hardware. Yes, I have one typo over here. Let me rerun it. So this looks fine. I'll connect USB terminal again, and I'll upload this code. Let us see what happens. The initial condition of your LDR, we'll check here, and we'll see the impression on LED also side by side. So this is showing LDR 0, and you can see the LED is also off right now. I'll try to cover it with my hand so that it can sense the other condition, and you can see LED turned on, and the signal also turned to be 1 for the LDR sensor. If I remove my hand from this LDR, means again it senses a bright condition, so the output is 0, and the LED also turned off side by side. So this is how in practical it will behave whenever you are installing it or deploying it in any field environment. Accordingly, the bulbs will be turning on and off. See, currently we are doing it with some demo operations like LEDs and buzzers we are using. But maybe in future, when you will be using some kind of real sensors, or maybe you want to turn on a real light bulb, or maybe some kind of alarm with this, you may need to use relays in that case, because the power supply in your area or the bulb in your area will work on the main supply only. So you may need to do wiring accordingly. A relay in your circuit you may have to add, and that relay will be used to turn on your switch accordingly, on and off, and accordingly the main supply will turn it on and off based on the response of your Arduino. So that is definitely a big project. Currently we are just trying to learn the prototype of this, that how these things happen. When you apply it in the practical circuit, then the relays play important role to deal with the main supply of your premises. So this we have added up with one more sensor we have updated here. Let me know everyone if we are good up to this, then accordingly I'll proceed further. Update me in the chat box if you have learned everything up to this level. Okay, great. So after this, we have the next sensor. I'll be using a soil moisture sensor. I have shown this sensor on the first day also. So this I'll be using for the interface today, and that interface will be creating by following a simple 3-pin sequence again. One will be your A0, other will be your ground, and then one more you will have is your VCC. So this sensor we are using right now, and you can observe here, this is the part we can insert into a plant. and this is the part we use as a reader module. They are connected together, they come together. Whenever you buy a sensor, they both come together with these wires, and then you have to use these additional wires to further connect this reader module with your Arduino. So again, the three pins you have, this is the extension further. Depending upon where you want to place your plant, accordingly a long length wire you can use, and you can insert this portion into your plant. So we'll be doing that further. But first what we'll do is I'll just connect my hardware over here, and I have this ground. I'll be connecting it in the ground section right here. Then this VCC I have used with the red wire. I'll be updating this in the VCC section. And then I have the signal A0 pin over here that I'll be using on available analog port. And I have pin number A2 free right now, so that I can use for translating the signal. So next pin in sequence I'll be defining here for my soil sensor is soil sensor, and pin number for this I have given is A2. Similarly, a variable I need, float soil moisture. This is my variable I'm inserting here. And further, since I'm using this on analog port, so there is no need to declare pin mode for this. Rather, by default, it will take up. We'll move further to the loop section, and I'll go to the last part here again, and one subsection I'll be creating that will be for your soil moisture sensor. And again, I'll be using similar type of part, same as I have here, similar kind of code I'll be using further, and that will be with specific variables of your soil sensor. So that will be with soil most variable that I have already created, and that should be as a float variable generally, because this may provide you continuous readings, so that I have declared already. And here now again analog read I can use, and this will be from soil sensor is my variable for the pin of this soil sensor, I hope. Let us verify that. Yes, this is your variable name, soil underscore sensor. So the same I have used. And now I'll use my serial print, the same sequence as we already know. So soil moisture I'll write here. I'll terminate this section. Then I'll write serial print, and inside this I'll paste soil moist, and I'll also add ln over here, and then this space I'll take down, so that again the readings get segregated from here onwards. So this completes your soil moisture sensor. If you have any kind of indicator to insert in response of soil sensor, again a loop section for that you can insert, that is your choice. So let me just run this part, and if it works fine, we'll be able to see the outcome for this also. So we are able to compile it, and now I can connect back this portion, and I'll just upload this code. You can see all sensors are on, all the LEDs turned on immediately, and we can see the outcomes of this. Your soil moisture sensor, when it is in dry area or when it is in air, it will give you higher readings generally. And when we insert it into some pot and then we apply some water, accordingly the readings will reduce. This is the by default function how it goes. For the dry soil, it gives higher readings. For moist soil, it gives lower readings. So currently this is what we are able to see. Since your LDR sensor is facing downward right now, so it is again reading it as a black. If I take it upside, and it will sense the brightness, accordingly 0 reading will come. You can observe here. So that is not of our concern right now. This is just the placement of sensor like this. We are more concerned about this soil sensor right now. So what I have here, I have brought one plant over here so that I can just show you by inserting into the soil. So this I am trying to place here for your easy visibility, and I'll just take up this section. I'll insert this into soil right here. So this is right now a little bit of dry soil. So accordingly, a little bit of change in the outcomes we'll try to see. Let me just find it. So you can see it was earlier somewhere into 900s or 1000 somewhere. Now slowly we will see little bit of changes in the outcomes. Currently it is right here, because this is still a dry soil. So what I'll do here is, I'll try to put little bit of water inside. You can observe this, I'm just inserting little bit of water, and accordingly some change in the readings we should observe. You can see 830, then 770. So depending upon what you consider as a safe level for water intake or moisture level in your plant, accordingly you can turn on your water supply or the irrigation system for the plants, and you can see the readings are reducing further. Along with this, of course, water sensor also you have. So maybe if you have some irrigation mechanism already inserted in your greenhouse area, so in that area definitely the tank levels also you can measure with that water level sensor. That will easily help you understand how much water you have in the tank, and accordingly you can check moisture level of your plants, and you can turn on the irrigation system automatically so that it can water up your plants. And maybe if the water level in tank is low, you can turn on your motor, or you can even automate turning on your motor. How you can do that? Very simple. There are two levels you can insert in your conditional statement. For instance, for a higher threshold, you can turn on indicator or alarm that water tank is full. For the lower threshold level, you can create a relay turn on condition, like whenever water level goes below 100, the relay should turn on, and ahead of that relay you can connect your motor that can fill up your tank from the main supply. So accordingly that irrigation system you can manage automatically. So I hope this was also useful for all of you, that we could just see how for plant health monitoring all the basic components we could add up here. And moving further, this basic section of code we have now completed, and we could measure number of parameters that includes temperature, humidity, CO2, then water level, LDR level, and moisture level of soil. So these all parameters we have seen by now, and the sections we can observe here. Now the next thing we want to do is sending all these readings to a cloud platform. That is the next task we want to achieve in this particular project. And in order to do that, you will have a very simple approach again. Either you can follow the same sequence as yesterday. If you remember, we have used ESP8266 yesterday, and with the help of that, we could just upload code to the cloud platform. That was your ThinkSpeak platform. Today, I'll show you one different approach also, so that you can just get well versed with all the techniques that are possible as a beginner you can start with. So very first thing, I'll just go to my ThinkSpeak platform that you can find right here. I'll be opening up the channels that I have. Just let me log in into my account first, then I can open up the dedicated channel for agriculture monitoring. So this third channel I can use, for instance, I have used it earlier also with these kind of variables. For instance, temperature, humidity, CO2, soil moisture, and water level, and LDR. These are the parameters, and you can see the previous readings from here that I may have obtained few days ago. So now we'll be updating new readings into this. Currently, you can see it says 2 days ago, and last number of entries are 44. So ahead of this, we need more entries now. So let us take our project to the second part now. First part we have understood, interfacing all basic sensors together. Now the second part is sending your data to the cloud platform. So for that, what we'll be doing here is, very first thing, we'll understand how to improve our sketch for that. So this is currently our basic sketch. This one I'll just remove right now, otherwise we'll get confused with this. I'll save this code on the folder so that I do not lose it in between. Now coming to the next part, I have here this ESP ROM module that you can observe. This chip I have here. Yesterday, I have used mini ESP board for Wi-Fi connection. That was your ESP 8266. Today, I'm using ESP32 Dev Kit. On the software itself, you can find it with name Dev Kit. So accordingly, we'll be interfacing it. Although this particular chip, as I have already explained to all of you, this works as a individual microcontroller as well as a gateway. But currently, I'm using it as a gateway since I have connected all my sensors already on a microcontroller, that is Arduino, right here. So this one I'll be using only as a gateway right now. Later on, you can change your technique. You can use this as an independent gateway as well as microcontroller. So that approach completely depends on you. I'm just trying to show you the one possibility that you can try over here. So what I'm doing here is, on this sensor we have the transmit and receive pins. On your Arduino also we have the transmit and receive pins, that is your 0 and 1. Either you can connect it directly with 0 and 1, and if you remember, we call that hardware serial. Or the second approach is, you can use software serial technique, and in that you can use any of the pins from your digital port to be declared as your transmit and receive pins, and the same you can connect here with your transmit and receive, and then start communicating. So now this part of code will be little lengthy, but no worries, we'll try to learn every part of it. First, I'll just modify the Arduino code. This code I need to modify first to accommodate ESP sensor or ESP gateway basically. So in order to communicate with this, first of all, I need two main lines, that will be transmit and receive lines available on my this particular chip. So I have here pin number 16 and 17 that I can use as transmit and receiver by default. On this chip, you have 2-3 different dedicated transmit and receive lines. Out of that, I'm using RX2 and TX2 lines. Accordingly, we can define it on the software side as well. So these two pins I'm using currently, and I can use it on any of the empty pins available on my Arduino board. For instance, the transmitter, right now I'll be connecting on maybe pin number 8, I have empty over here. And similarly, the receiver I'll connect on pin number 9 because I have these two pins empty in my digital port right now. So these two are connected. And for power supply to this particular chip, I'll be using a separate cable from here because I'll be uploading a code also to this particular chip. So I will be using a separate cable. Once you have uploaded a code, you can use this directly with your Arduino by using 3.3 and ground connection. So it will be powered on by the Arduino also directly. However, in my case, I'm using it with the outside cable. So that will be powering on it, and only two pins we are connecting right now. So hardware I have connected here. And on the other side, I'll be writing the software. Since I'll be using software serial because I'm using pin number 8 and 9 from my chip over here. So the first thing I'll do is I'll include a library that we call software serial. If you remember, we have seen this library yesterday also. This software serial.h is my library, and I'll enclose it within these signs as per the requirement of the software. And similarly, for this software serial, I'll declare one ESP object inside which I'll pass my pin numbers. For instance, RX and TX respectively. So your pin number 8 becomes RX and pin number 9 becomes TX on your Arduino board. And opposite we need to connect on the ESP. So right now, if my pin number 8 is a receiver pin, it has to be connected on the transmitter pin of your ESP. And if your pin number 9 is the transmit pin, it has to be connected on the receiver pin of your ESP. This concept we have learned earlier also. Opposite connection we always make. So we are ready with that. This section we are done with, and now we can proceed further. And in the setup section here, I'll be modifying it again. I'll be using serial, not serial, ESP dot begin, because now the name of object is ESP. And this I'll be using, for instance, with a baud rate of 1150-200. You can even use on 9600, but I'm using it on a separate baud rate, so that text doesn't interfere with each other. So a separate baud rate I have assigned 1150-200. Then we will move to the loop section. And in the loop section, by the end of it, I'll be creating one more sequence, that is to send data on the ESP board. And for this, I'll be using a very simple technique. I'll be using a comma sequence. Again, there are so many ways of doing this. I'm just showing you one simple technique. Otherwise, later on, while doing your practice, you may find hundreds of other ways also. What I'll do is, yesterday I have written a very lengthy code on the Arduino part itself for connecting Wi-Fi, for setting up channels, everything I have done over there. But today what I'll do is, on the Arduino part, I'll just use the transfer sequence. ESP print means on the baud rate of 1150-200, we will write the pin number 8 and 9 with these sequence of outcomes. So ESP dot print, the next value I have is humidity. Exact variables I have to use that I have declared earlier for storing my values. Then ESP dot print for my next variable, that is CO2. Again, a comma sequence. This comma sequence I'll use while extracting my variable values on the ESP board, because I'll be writing a code over there also. And then in order to separate between one to next value, I'll be using comma separation. So that will be used over there. That is why I'm adding this sequence over here. Then ESP dot print with your soil moist value, and again a comma sequence. ESP dot print, next for instance we have water level. Make sure you use exact same variable names. Then we have ESP dot print, and the last variable that we had is LDR. So for the last variable we'll use LN, because that will ensure the termination of your sequence. Next line means, so when the comma sequence ends and the next line appears, it will consider it one sequence of message, and that will be updated accordingly on the other side of the code. So this simple addition I have done on the Arduino side of the code, and the delay also I'll keep as it is. If you want to increase delay to transmit data accordingly, you can do that. Or maybe I'll add a little bit of more delay over here, maybe of 2000, to ensure it gets enough time to transfer data. And I'll check if this code is working fine. I'll compile it. So I have a typo somewhere here. Okay, this I need to terminate. I'll run this again. So this code is working fine. But if I upload this code on my Arduino hardware right now, we will see no changes in the outcome, because the data we are transferring to this ESP board, and we should write code for this first so that we can see the impact of this data transfer on this chip. So let us write one more code now. I'll use a separate window for that, because this already created code will be updating on the Arduino board, and this newly created code will be updating on the second chip, which is your Wi-Fi chip. Yesterday, what we have used is, we have used mini ESP gateway that doesn't require any specific upload of code. Rather, it takes code directly from the Arduino. So Arduino will be the managing unit over there, and it will manage the ESP also side by side. But here we have used an independent unit, and this requires you to write code separately for this one as well. So what we will do is, I'll just insert this section with the specific set of codes. This will be little lengthy code. So let us see how much time we have to write this code right here. And accordingly, if I need to take any existing code from the folder, then I'll take that. But I'll first try to write it for you so that I can explain you every part of this code. So the very first thing we need is a Wi-Fi library that help us to connect with the Wi-Fi using this particular setup. Second, we have include, we need ThinkSpeak library in this case. So these are just two different techniques to include libraries. Any of them you can follow. They get common with majority of libraries, but generally we recommend that when you have any global library, you can use this form. Global library means that is used widespread and is by default also available on your platform. And this type of inclusion we generally prefer when there is a specific application based library, so then we can use this type of inclusion for the library. But otherwise sometime with many libraries they work alternatively as well, so you need not to get confused with them. Then further, I'll declare all the variables here also, because I'll be extracting them one by one in this section. So what I'll do is these variables I'll take up and I'll place them here. And this time I don't need this one, because I'll be getting that value from the transfer data automatically. So these variables I have used. After this, I'll be inserting one more thing, that is your Wi-Fi credentials. And for this, I'll be using a technique, constant char SSID, and I'll be passing a SSID of Wi-Fi connection over here. So I'm using my Wi-Fi connection over here. And accordingly, when I'm using this star mark with char variable, it means SSID can be of any length. So when we don't want to restrict the variable with the length factor, we use this star, because anyone can have this ID with any length. They can have 2-digit, 5-digit, 10-digit, anything they can have. So we will not restrict them with the length of the password or SSID. And then we have, I'm just passing a sequence for the password, just a random password I have created for the connection right now. And then the next part is I'm declaring a server for posting my data. If you remember from yesterday, 80 was your port number for ThinkSpeak. So ThinkSpeak server I'm creating here on port number 80. And this you can use based on your requirement, capital, small, that is your choice. I'm using a server with the small letter over here. Then Wi-Fi client also I'm creating with name client. So my ESP I'll be using as client further, and ThinkSpeak I'll be using as a server further whenever I use it in my program. So this sequence also I have created. After this, the next part, if you remember in yesterday's code, we required the URL of ThinkSpeak or the IP address of ThinkSpeak. Any of them you can pass. So this time, yesterday you have learned what is your IP address of your ThinkSpeak, that you can update. But I'll show you other way out also. We can sometimes use URL also. That URL also works fine with your codes. Alternatively, you can use any of them. So what I'm writing here is domain name for storing data. And that again I'm using with constant char. And here I'm passing a variable server name equal to, I'll be using it directly as per your sequence in ThinkSpeak platform api.thinkSpeak.com, and I'll directly go to the update section in this. There is a dedicated update section for your value updates, and that closes with the port number 80 automatically. So this portion I have created. This is the standard format we are following as per ThinkSpeak sequence. So after this, I'll be updating ThinkSpeak channel details. Next important things you need. For the channel detail, yesterday we were using just one API key. That is possible when you are using the mini ESP module. In case of your this big ESP that we are using today with ESP32, we need two things. One is your channel number. So for this, I'm using my channel number variable, and that is 3 right now. If you observe my channel right here, that was third channel in the sequence. This one I'm using. So 1, 2 and 3. So that is why third channel I'm writing here. And similarly, I'll be using it. Second thing I need is API key for my channel, because that will be a secure key. Without that, anyone cannot pass data to the channel. So API key I'm updating. Within inverted commas, we have to write it, and I'll be taking it from my channel right here. So I'm going to smart agriculture section, and here I'm taking up the API key of the channel, and I'm getting back to my code, and here I'll be updating this one. I'll enclose this again. I'll terminate the line, and then this completes your ThinkSpeak updates. This was your Wi-Fi credential. There was one more thing required for your Wi-Fi. That was the pin numbers that we have declared on the hardware side for your ESP board, and that was hash define. RX pin number we have used is pin number 16, and TX pin we are using is 17. So these two I'm using with define. I need not to apply this section. So these I'm making as an update in the code. These pins are basically on the hardware side as it is, as pin number 16 and 17 on your ESP board. And these are the random names I'm giving it so that I can use them as it is further. Since this is the second channel of your transmission and reception on ESP, so I have used it pin 2 over here. Moving further, the initial sections we have completed. Now I'll go to void setup. Inside this void setup section, I'll be passing few details. The very first thing is, again, serial begin I need, and inside this serial begin, one of the baud rates I'll be passing. Second I need is the serial begin for the pins that I have declared over here. Note that these are by default receive and transmit pin on the hardware. So I don't need any software serial here. Rather, what I'll be using is serial 1. That is for your hardware serial sequence. Yesterday we have learned this. And for this, I'm passing the baud rate. And then I'm using a dedicated sequence here for the serial interface. This is by default code they provide for the serial interface over the hardware channel that I'm following. Then we have RxP2 and I have a TXP2, the pin numbers that I have defined for this communication that I'm updating here. After this, I'm updating the next sequence while your serial port is activated. Accordingly, it should write serial print ln ready. So as soon as your this serial 1 connection is ready, I'll be writing here for as soon as this connection is ready and this connection is also ready, it should print ready on your screen. This is just an optional part I'm adding for initializing my code sequence. After this, again, we'll be adding up more sequences. First is Wi-Fi.begin. And inside this, we may need to pass the SSID and password that we have created on the top with exactly same variable sequence. I have used small letters earlier, so the same I'm passing here. Then here in this section, I'll be updating the connection sequence, serial.print. Inside this, I'll be passing connecting. You will see how it will appear when we run the code. Then you will observe how this will impact your final outcomes. Wi-Fi.status. And inside this, we will pass if not connected, it will start making connection. If it is already connected, it will skip this. And inside this, what we'll do is delay for maybe 500, a mini delay I'm adding, and then serial.print will do, and that will pass with some dots over here. If you can just connect all these points, what we are doing here, you can observe it something like, as long as your system is making connection with the Wi-Fi, connecting dot 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 will appear in sequence. That is a common technique you will see whenever we do connection on the Wi-Fi. Even if on your phone you are trying connecting dot dot dot, it will show as long as the Wi-Fi is not connected. So that kind of sequence we are creating. So it will just check, if not connected, it will try connecting, and accordingly dot dot dot, till then it will be displaying. After this, I'll be writing here serial dot print ln, little bit of empty space, so that after these dot sequences some space gets inserted into my page, and then serial dot print. Inside this, as soon as the connection is done, I should get information about the network IP address with which it is connected, if you need to verify that. Otherwise you can keep it empty, no issues in that. So this static text first, and then we need the exact value of your IP, so that I'll get with local IP function available in my platform. So that I'm updating here. So after this static text, it will update the local IP address that it is getting for the Wi-Fi connection. Once it gets Wi-Fi connection, we will begin the server. This server on port 80 we have already declared. So I'll begin server, and for connecting with the server, it doesn't require any baud rate. So that I'm updating here. ThinkSpeak begin dot begin I'll write, and inside this, as a client I'll be publishing on ThinkSpeak, because ThinkSpeak is a server, and as a client from here I'll be publishing on that. So that sequence I'm updating over here. So this portion completes your setup section. We have added so many things in between. I think that for many beginners, this may be a little bit complicated, but I'm just trying to show you every part of the code in detail so that you can understand how we do it. And in future, you will be able to create your own sequence of codes also. Then we come to the void loop. Just a few more details we need to update inside. In void loop section, because now we are planning to receive data from Arduino, then publish that data. That is our option. Publish that data locally on the serial monitor to ensure whatever we are sending from the Arduino, that same we are receiving on the ESP, and then send that received data to your ThinkSpeak platform. 3-step sequence we can do. So let us start with the first step. First of all, in case if your Wi-Fi status, we'll check first of all. If the Wi-Fi status is connected, then what we will do is Wi-Fi client will be activated as client. This we have declared already also. So the same sequence we are using, and then I'm adding a delay of maybe 10,000 over here so that it can wait for 10 seconds. After this, if serial 1 dot available is greater than 0. What does it mean? When we are sending data from your ESP pins, receiver and transmitter pins, as soon as data is available on that area, means when it is greater than 0, by default it will be 0 always, but when we start receiving data, it will be always greater than 0. So that condition we have updated here. If serial 1 started receiving data, then what we'll do first is string data sequence I'm creating. It reads data in the form of string by default. The function I'm using here is string function. You will see I'll be using read string until. Observe this very carefully. We'll connect with the sequence that we created on the Arduino side. Next line, read string until next line. And how you will connect here with the main code that we have created on the Arduino side. I told you earlier that when the message completes, we will add a next line. This ln I have added means it will read all these values until next line. So this is the first thing we are updating here. Then getting back to the sequence, once it has received one packet sequence, then serial dot print, and we will see right directly data received from Arduino. that we are writing here, and that will be updating in the form of your data variable, so that it simply prints that particular data that we want to see. And then I'll add a ln sequence over here so that it goes to the next line. And again, I'll be adding some empty spaces to organize my code. Up to this, we have just received your data. And that data, as we remember, we have sent in the form of comma sequences here. We have observed this. So when we are sending something in the form of comma sequences, we need to make sure that we separate values from those comma, because an individual value only will be sending to the field later on. So we need to separate those field values. And in order to do that, I'll be using a simple conditional statement again. Uh, I'll be using just a segregation with int I1, first variable data dot index of, this is the segregation sequence I'm following for comma. Up to first comma, it will consider the first integer that it has received. You can receive it in the form of float, in the form of anything. What currently I'm using is I'm just getting the index numbers. Index numbers will be in the form of 0, 1, 2, 3, 4. So that it is getting directly from here. So I'm giving it name I1 first. Then int I2 data dot index of, and inside this what I'll do is comma separated but with I1 plus 1. It clearly means the next comma after first comma. I1 plus 1 means first it has already received. After that, when it receives next comma, within that it will assume the next index values. Similarly, we will do with the further sequence depending upon how many bits we are receiving from the data. So this goes with the second. Then we will take up with the next sequence for the fourth element. This will be with 3 onwards. I'm using this wrong. I'll be updating the numbers on this side. That will count further from comma. Next one for I5. This will be I4 plus 1. Then we have I6, and this will be 5 plus 1. So this is what we need. We are sending 6 variables from there. If you remember, this is your first variable, second variable, then we have third, fourth, fifth, and sixth. So 6 index elements will be declaring from here. Now I have stored these values in my I1, I2, 3, and I4 index values. Now let us extract this value. Data dot substring, because this is a long string sequence. From here I'll be now segregating things. 0, that is my first sequence I'm getting from I1 index, and I'll be converting it into float, because variables in the beginning I have declared is as float. Only this isn't, or I can keep this one also as a float. That is our choice. Later on it will be just showing 0.0 accordingly, so that will not make any major difference. So what I'm doing here is to float conversion I'm doing, and same I'll be doing for all the variables in sequence. Make sure you are using the same sequence as you have used here, because accordingly it will be decoded. So humidity is my second variable, and accordingly I'll be updating this sequence, and this will be this time I1 plus 1, and next will be here I2, and I'll be taking the next variable, that is my CO2 variable, and here I'll be using I2 plus 1, and this will be I3. The next variable I have is soil moist, and here I'll be updating the next variable sequence up to I4. We are just extracting the intermediate values accordingly. Then we have water level variable, and inside this I4 plus 1 up to I5. Then last variable I have is LDR. Make sure you have defined variable according to the same sequence up to I6. And this number of float variables I have created only. So this completes my one extraction sequence. So I'll close this bracket over here. With serial available, this bracket I'll be closing right here. So this section you can see serial available is done. So this data available from the serial port I have extracted now. So next to this, what I can do is I can just print all these data elements. So what I'll do here is display readings on serial monitor. So for this, first I'll use serial.print, and the first variable I have is temperature. Then serial.print I'll be using again, and here I'll be updating my temperature value. I'm just trying to make it clean so that you can identify all values clearly. This is the first variable. The same sequence I'll be using with ln so that it gets updated in the next line. Then we have this one for humidity, and here I'll be updating the humidity variable. Next I have for CO2, and here also I'll be updating this bracket sequence has to be without inverted commas. We always need to keep it in mind. The dynamic sequence doesn't require inverted commas. Only static sequence requires inverted commas. So here we have the next variable, that is soil moisture. So inside this I'll be passing soil underscore moist variable. One more we have is with water level. So that I can update here as water underscore level variable. And the last one is with LDR. And variable for this, I hope I have defined LDR. So that sequence I have updated. And then for instance, for the serial print, I need a proper gap. So I'll be updating just few stars just to show the segregation of my next sequence. This completes your printing sequence, the second stage of your display on the ESP board. First is extraction of serial board data. Second is display of readings. And third level is sending this signal to the ThingSpeak platform. Just 5-10 lines I'll be adding here. It will take 3-4 minutes more. And then uploading part, we can check maybe after a break also. So let me first complete this portion. ThingSpeak dot set field will be using here. First field I have is temperature based on what you have opened up in your ThingSpeak channel fields right here. The channel settings you can check, and you can have this sequence exactly in your update also. So first field will be updated accordingly, second so on. So getting back to this portion right here, and then second field I'll be updating with humidity value. The next field is my third field that will be updated with CO2. Then I have my fourth field that will be updated with soil moisture. We can verify that side by side if it is on the same level with your channel. Then we have water level. After this, the sixth variable we have is LDR. So accordingly, I'm updating each one of them. And this is your field setting we are using. We generally have 8 fields. Out of that, only 6 we are using right now. And then I'm creating one X variable that contains this entire message while sending from your ESP to the platform, and write fields function I'm using here. So my channel number that I have declared on the top along with the API key I have already used. And based on this, if X is equal to 200, this 200 is basically your dedicated code for transmitting data to the ThingSpeak platform. So if this channel field write function returns code 200, that means a successful transmission. So accordingly, it will print here channel update successful. This is the channel field successful update. Similarly, in case if it fails to transfer, in that case we can print the error code. For instance, serial dot print, I'll write here, and we'll write here a simple sequence problem uploading uh, channel fields, and after this we will write http error code that it will automatically get from the x string x that we have already created. So success or failure code you will get from the x automatically. You can give any variable name to this. I have just taken one random variable over here. And then we have again a little bit of delay I'm adding, like about 10,000 or more as per your requirement you can add. And the brackets I have used all together with all the declarations, so hopefully brackets will be also fine. I can just run this to check if there are no errors, and accordingly we can furthermore update into ESP board. Okay, we'll have one error over here because the board is not selected right. When you are using DevKit, you need to use this. Do it ESP32 DevKit V1 board. I'm selecting this one because the functions will not match otherwise with other board. They will match with ESP board only. So we are just compiling this sketch, and we are already on the verge of first session. So I'll not take it further in this session. Rather, we can take a small break, and then I can upload this code on my hardware, and then we can visualize the outcomes of this, and then we can continue further accordingly. So I'll just stop it here. It is compiling in the meanwhile. Generally, it takes longer time to compile code for the ESP, depending upon its features and specifications. So it will take 2-3 minutes